Okay. Then Grace, will you introduce our speaker?
I'd be very happy to, because I don't know him personally, although he seems like a really nice guy. And he knows he's a TV personality, so he knows how to do this, and I don't. I'm going to let him introduce himself.
Thank you, Grace, and thanks for inviting me to talk to your group. Can everybody hear me okay? Okay.
Again.
Can everyone see my screen now?
Yes.
Okay. So I'm a meteorologist at CBS 11. We're right over there inside the 820 loop on I-30. Maybe you've seen our big white tower there. That's where our studio is at. I've been there for about 13 years. I've been a meteorologist for over 35 now. And I primarily do the weekends and cover severe weather. And I do also a series, a gardening series that is on every Friday. And Gardening 101 is something that's, I guess it's in its third year now. I've done about 160 episodes. I am a meteorologist first. I covered a rather large area. We live in a huge metroplex area now, as you know. It's gotten huge. I don't know if anybody out recognized the outline there in yellow, but that's the state of Connecticut. It's not as big as DFW. So just to try to picture Connecticut completely paved over, and you'd have the metroplex. And I always tease people that come into this area to visit and say, hey, I've got a friend in so-and-so place. And I always go, well, from Royce City to Weatherford across the metroplex, it's 92 miles. From New York to Philadelphia, it's 94. So it'd be like saying, hey, I'm in New York. Let me visit your friend in Philadelphia. I'm going to be throwing a lot of statistics at you tonight. I'll try not to go too fast, but you'll see a lot of numbers and a lot of stuff that I've been researching now for the last decade. We're quite fortunate here. We have a good climate record. It goes back 100 and now 124 years. It started in downtown Fort Worth. Hourly observations, which actually are very important to research, started in 1909. It's been at the DFW airport since 1974. If I had to summarize what that 124 years says, as we look over a long stretch of time, I could sum it up really quickly. Temperatures are getting warmer. The growing season is getting longer for you gardeners, but we're also getting more extreme weather events. They're becoming much more common here in the last 2 decades than they were in the previous. So I normally give this talk to garden clubs. So I usually start with the good news, and the good news is that the growing season is getting longer. It's seen all over the United States. We've gained about 17 days here. Of course, the downside, that's a longer allergy season, of course, here as we are waiting for the first freeze usually comes around Thanksgiving to end that. But we do suffer from allergens in the air, kind of unusually so. It has a lot to do with our flora, as you know, and just the way our climate works here with the longer growing season. But supposedly there's only one other city that's worse than DFW as far as allergens in the air, natural allergens. I would like to just go through the seasons. It's easier to explain what we have seen climatologically change in this time span of record if we go through the seasons one at a time. So we'll start with winter. Winter basically is getting shorter, it's getting warmer, and it's also getting more extreme. We know that it's getting less cold less often, probably one of the more remarkable things to look at is how the cold comes in, and it can be very cold, but it rarely sticks around. This has been a trend over the last 30 years, and it's really accelerated in the last 10, where we do get a winter here, but the really cold air of winter, which you would describe as a typical, say, January day, comes in spurts. We get 4 or 5 days of it, then it warms up again. 4 or 5 days of it, then it warms up again. It never kind of locks in. Earlier in the climate pattern, that was much more common. We're getting fewer nights where we get below freezing, which would be expected because of the urban heat island effect. As our metropolitan area has gotten bigger and bigger, the nights, the freezing nights, have gotten a little bit fewer. We have almost 2 weeks fewer nights of freezing now. I talk about how winter is getting warmer, but it's also getting a little bit more weird. We get stranger things happening. I think December 2021, if y'all were here for that December, it was remarkable. It was the warmest on record. The average temperature, that's the high and the low divided by 2, and you do it for all the days of the month. The average temperature was 61 degrees, which bested the old record for the warmest December ever, which was 54 degrees. Now, the difference between averages like that is basically unprecedented. We've never seen that before in any of the records. The difference between the warmest month and the second warmest month being 7 degrees. But anyway, when you look at December 2021, it was the 11th warmest November on record. So it was warmer than your typical November. In fact, it was almost in the top 10 warmest Novembers ever. And we're talking about December. I'll try not to bore you this, but if you study statistics and you remember what the standard deviation does, you know, what's that's telling you? It's telling you the likelihood of a number in a frequency designed by a data set. Our data set's 124 years. December, that's the 11th warmest November, is the standard deviation that's closer to 4. So basically, there's no statistical suggestion that it would happen, but it did. It happened 2 winters ago. The top 2 warmest winters we've ever had here have happened recently, 2016, 2017, and then just as we turned the century. In fact, if you look at the 10 warmest winters at DFW, 5 have happened this century. And you'll hear me refer to this a lot about this century, because when you look at the records, things started to really change when we got into the year 2000 beyond. Honestly, it started around 98. But ever since then, we've had kind of a new kind of climate here. Let's talk about spring. In a nutshell, it starts earlier. For me, moving here 13 years ago, I was quite excited that we have 3 growing seasons in North Texas. With the spring season, you're able to get greens out and a lot of crops, but before the summer heat knocks them down. So I plant around Groundhog Day, just probably 10 to 12 different things, depending on the year. And the good news is that that works pretty well nowadays, because if you plant around Groundhog Day, that stretch of 6 weeks has been getting warmer. You still get extremes, you can still get a freeze, but as a whole, you're getting warmer days. The top 3 warmest springs have all happened in the last 15 years. In fact, if we look at the 20s warmest springs at DFW ever, and the 100 and like I said, now 124-year pattern record, we have 12 of them in the top 20. If you look below, that's one of my research tools, that all the data is from every day is in there, and I can pull out certain queries by season, by day, by stretch of days, but what you're looking at is all the springs. These are meteorological spring, which goes from March 1st to May 30th first. And of the top 20 springs, I highlighted in yellow all that have happened since 2000. So you see a disproportionate share have happened this century. We all know about summers here. When I talk to the gardening groups, you know, summer is basically the Rubicon for us. You try to cross your plants over summer. Summer is the acid test of any plant you try to grow in North Texas. It has to survive our summers. And our summers, unfortunately, are getting hotter. And more unfortunate, the nights are getting warmer. And I'll explain that in a second because that's taking quite a toll on our plants. 2011, the first year I moved here, was the hottest summer on record, where we had 71 days. It got to 100 degrees or above. The third hottest summer on record, by the way, was this one. And last year was the fourth hottest summer on record. So unfortunately, this trend continues of hotter summers here in the last 20 years. Of the 20 warmest summers ever, 9 have happened this century. We're getting more 100-degree days, as you would expect, with the summers getting warmer, and 100-degree days, sort of the benchmark around here of a hot day. Though I dare you to walk outside and tell me the difference between a 99-degree day and a 100-degree day. We use it as a number, and it is a little arbitrary that it's the first 3-digit number, but it does turn out to be a pretty good indicator of how that summer is going. We're getting hotter summers and we're getting more 100-degree days every summer. It's now we average 23 per year. And that's becoming a little meaningless because we're getting a lot more than that now. I think what is most surprising in the research I've been doing is that it's not only getting hot, it's getting really hot. That if you look at the previous 100 years and you take all the 100-degree days and you see rather obviously that if it's going to be a 100-degree day, it's between 100 and 104. There's a very small range of hot here, traditionally. But that's been changing. When you average out the first 100 years, 13% of the time, if it was a 100-degree day, it might hit 105 or higher. That only happened 13% of the time. So 87% of all 100-degree days are between 100 and 104. But lately, when I say lately, the last 10 years, we're getting a higher percentage of really hot days. This year, 47% of all the 100-degree days were 105 or hotter. So the intensity of the heat is turning up as well. We're getting longer streaks of 100-degree days, which again is no surprise given the fact that our summers are warmer. But it does show a trend where we are locking down longer in periods. That includes wet periods, brutal cold periods, unusually hot periods. They kind of lock down these weather patterns now, more so, I should say. This is all about trends. And you need decadal trends to really make any conclusions. Of all the things that, oddly enough, are affecting plants around here, this might be a top culprit. It has to do with the biology of plants and their ability to shut down at night. When nights are at 80 degrees or warmer, plants still think it's daytime. Some of them do. Their stoma is still open. In order to close their stoma, they need photosynthesis, but they can't do that at night. So they get caught with their stomas open overnight and they evaporate their moisture inside their flesh. their body. So they dry out overnight. This is a source of some really big stress on plants, and there doesn't seem to be a lot you can do about it. But you take a look at the frequency of very warm nights here. 7 of the top 10 have happened since 2000, and frequency of 80-degree nights. But again, like the 100-degree days, not only is it 80 degrees, it's getting warmer than that, or I should say, it's staying warmer than that. Very warm nights, 84 degrees or above, or what is today on this date our typical high for this time of season. A night where it stays at 84 above is just new. I mean, we just haven't seen this in the record books. From 1899 to 1999, it happened like once a decade. And now it's happening at least once a year. And you talk about 85 degrees as an overnight low. Keep in mind that the warmest night we've ever had is 86 degrees. And that's happened actually several times, but it's never been 87 for an overnight low. But 85, there was only one in the previous century. And now we've had 19 of them since 2011. So these very warm nights are becoming more common. In fact, just this summer, we went a little over a week where the temperature never got below 80 degrees. We broke a record. It was 377 hours. And we had 17 record lows at DFW. Actually, now it's 19 because we broke some here in the pair of 100-degree days that happened just a couple of weekends ago. The thing about fall, if anyone has an opinion now when fall starts, I really would like to hear it. Fall is just, it's getting squeezed from both directions, right? Summer is hotter, lasting longer, winter is shorter. So the big question now is, when are we going to call it fall? Certainly you couldn't use September saying it's fall, but falls have been getting much warmer, more than any other seasons. Of the top 10 warmest falls on the record, 5 or 6 have happened just in the last 16 years. We have a chance even of this one being very warm. So those are the 4 seasons. What does it mean when we look at for the year? I don't know how many have seen this chart before, but you're looking at 123 stripes. Blue means that year was below average, and red means above average. The average taken of the 124-year period. And you can see the Dust Bowl years. That's where the red starts showing up. You see the 50s. If you were here during the 50s, there was a tremendous heat wave and drought. It pressed back to the east, the edge of the southern deciduous forest that had been here since, the last ice age retreated and the southern forest developed. That's the forest, the hardwood forest that goes from the shoreline of the Carolinas all the way into East Texas. At its time, it was the largest deciduous forest in the mid-latitudes in the world. But after 55, it retreated. It retreated almost 2 counties to the east and never returned. As we go into the new century, you see what's happened. All of a sudden, everything is red. And bright red because they're the hottest years. Of the 5 warmest years, they've all occurred this century. The top 5 have all happened basically since 2006. This year, by the way, is currently the hottest year on record, but we still have, quite a bit to get through to see if that changes. But as it stands as today, because I looked right before this meeting, this is the hottest year on record. Since 2011, we've had the warmest year, the warmest spring, the warmest summer, the warmest fall, and the warmest winter. That's all happened since 2011. When I said the 2 points that not only are we getting warmer, we're getting more extreme, it's like it'd be more accurate to say not global warming, but global weirding, that more unusual things are happening. And I can explain that as well later if you'd like, but it has a lot to do with the fact that the air is warmer, it holds more water vapor powers thunderstorms. the storms are stronger. In 2011, let's just look at the last 3 years. And I could probably do a couple of pages of charts just like this of all the extreme things that have happened this century since the year 2000. But we'll just look at the last 3 years. In 2011, we had the coldest 3 days in DFW history, which is quite a statement because when they started taking weather observations in 1899, they were in the midst of an historical cold wave that was sort of like, God telling you, don't settle here. I mean, the winters were brutal. Many of those records still stand to this day. But even with that, in 2021, from February 14th, 15th, and 16th, those were the coldest 3 days we've ever seen in DFW's record. Of course, because of the loss of power, it was also one of the most expensive weather events in Texas history. On Valentine's Day, because Mother Nature loves irony, the high was 14 degrees on the 14th, on Valentine's Day. That was the high for the day. The record low for that date was 18. In other words, on all the Valentine's Day, the coldest the temperature had ever gotten at night was 18. Now we just had a sunny day where the hottest point of the afternoon, it only reached 14 degrees. We were below the record low, and that had never happened. Of course, it's North Texas. We had a high of 18 degrees, also a record on the 17th. Transpose that because 6 days later, it was 81 degrees, and we didn't have another freeze. That was the last freeze of the season. Then the next year, we went the second longest streak on our record of no measurable rain. I don't even remember that summer, but the plants had already gone through a shock of cold, and now they were hit with the second dry, second hottest period we've ever recorded here. The average high was over 100 degrees in that drought, and there was a lot of plant death because they'd already were stressed from the cold. Then on August 12th, that night and into the morning of the 13th, it rained 9 inches of rain. That 9 inches of rain was the second biggest rain event on record. And we didn't get another 100-degree day. It ended the drought, ended the heat wave, and we went in and enjoyed our fall. Then this year, 2023, we've had the third hottest and fourth driest summer. August was the second hottest month ever recorded, and now the second hottest September ever. So just look at the last 3 years and you can see all these extremes happen. But like I said, I could make a couple of pages of this at least. We had the most tornadoes in a year in 2015. We had the wettest year ever in 2015. And then 3 years later, we had the second wettest year ever. At the same time at 2000, we've had the longest dry spell ever. We've had the most 100-degree days in a year. That was the hottest year ever, 2011. The biggest 24-hour snowfall, that was in 2010. And the earliest last freeze ever, which was really remarkable. Because before that happened, the earliest freeze ever was kind of standing off all by itself in the first week of February. You had to go then kind of almost towards the end of February to find the earliest last freeze. And then that was bested by almost a month. In 2017, the last freeze was January 8th. It did not freeze again. As everything is warming up, so are warming the oceans. And I'll show you some of the latest information on that in just a moment. But the Gulf of Mexico is getting warmer, and any tropical system that gets into the Gulf is producing bigger rain because of that. Warmer air, again, holds more moisture, holds more water vapor powers thunderstorms. What you're looking at in those brighter colors, the yellow and green, are basically areas that got as much rain as we get here in a year. It was the Hurricane Harvey event that was the costliest weather event in Texas history. It cost us over $150 billion. It was the biggest tropical rain event ever recorded in the United States. Along the channel in Corpus Christi, in a town called Nederland, Corpus Christi. Is that right? I'm sorry, no, that's not right. It wasn't Corpus. What's the other sea town further north on the coastline? Anyway, in Nederland, Texas, along the channel there, they got 60 inches of rain in 5 days. The aerial coverage of 20 inches of rain was bigger than West Virginia in Texas, and the Harvey itself did something that had never been seen. It went on shore, looped around past San Antonio, and came back to the Gulf, and the whole time it stayed a tropical storm. It was a tropical storm for 117 hours on land. The previous record was less than half that. So this huge tropical storm came on shore and was so big it stayed a tropical storm the whole time before it went back out onto the ocean, into the Gulf, I should say. It came on shore in Louisiana. It was estimated to drop 19 trillion gallons of rain over Texas. The new Doppler radars do a much better job estimating total rainfall because they can look at the size of the rain droplet now. And I know 19 trillion gallons doesn't mean anything, so I did the math on that. It would cover all of Texas in 5 inches of water. You know that sign at Texarkana? It's a joke. Texarkana, 1 mile. El Paso, 850. Try to picture driving all the way to El Paso, both sides of the highway, the whole way. There's 5 inches of standing water as far as you can see. That's how much water came from one tropical storm. The Gulf of Mexico is warming up, and these storms are going to continue to bring in monster rains. They're also going to pump up our humidity here, which is going to be very troublesome when we get to hotter summers. We broke a record this summer, by the way, with more humid days than we'd ever seen with temperatures this hot. What you're looking at is two lines. The blue line is the seasonal change of the water temperature in the Gulf of Mexico. And it has been averaged out between 1991 and 2020. So you can see the arc of how it goes, how warm it gets in August, right? The black line is what happened this year. Now, I have only August 10th. I'm trying to get the monthly update because I think it extended past the chart. But that's the difference between this year and the previous 30 years of record. We have seen the Gulf of Mexico break temperature records. We didn't, most of the scientists that watched the Gulf of Mexico didn't believe it was even possible, but it did it this summer. This is the part of the lecture where I'm talking to garden groups, and I'm talking about what I did in my garden to try to alleviate some of these changing conditions. And I recommend them to gardeners. The first thing is to raise your garden beds off of ground level. It has everything to do with the intensity of the rains that we're getting. We're getting bigger rains. I learned the lesson the hard way. I got all excited first moving here, immediately changed my yard over to a garden. I think it was sometime in May, I got 5 inches of rain, and it drowned every bit of my garden. So I put in raised beds. Because we're getting such hot summers, I use shade cloth now. I have a very small backyard. I have a small backyard, but I use shade cloth to keep the sun off of it during the afternoon hours. I've also gone to drip irrigation. It's certainly the most efficient, and certainly the plants like it the most. It has a lot to do with how deep that water goes when you use drip. And it's efficient because it's under my mulch. So I'm not spending so much in water to keep my plants alive. Because the growing seasons are getting longer, I've gotten better at using frost cloth and growing transplants inside my house and then moving them early into the season out into outside into the dirt. But you can be rewarded if you use your frost cloth, because we can get these freakish kind of cold nights, one or two of them, and then suddenly we're back to warm weather. That's going into winter and coming out of winter. So you can extend your growing season even longer. I've extended my growing season here sometimes all the way to early January, just using frost cloth and watering. I try to help my plants on this trend of warmer nights. I get out there at the last light of day when there's still a little sunlight to help you out. And I mist the beds, not the plants. I mist the beds, and that last bit of sunlight does the evaporation for me. And I try to take the heat out of the soil on these warm nights and help my plants try to shut down for the night. I've had limited success in the last 2 years doing this, but we've had a record the last 2 years. We both had record nights of warm nights. To the left, by the way, in this picture is the house I bought. That is actually the day we decided to buy it. There were other buyers here at the time, but you can see it was all grass. On the right is that if you look at that window to the left of the fuse box, that's the same window. I took out all the grass. There's no grass in my backyard at all. It's all raised beds and hardscape. And I use a series of canopies, but I also had to drain my yard because of these big rains and my yard relatively flat. What you see, that gravel path is actually a French drain. Both sides of my backyard have French drains that go out through the back. I have a little bit of elevation to get that water out. That, and along with my raised beds, I've been able to keep my plants from drowning. And then I protect from the afternoon sun. I use shade cloth so that usually about 3-4 o'clock, there's no sun on my beds. And I try to also shade all that hardscape too, so it doesn't build up the heat that it slowly releases at night. On the west side, I have put in a trellis and 2 rows of plants to try to block the western exposure to my house, not only to help with my cooling bill, but again, to try to keep my whole area cooler. On the left now, by the way, I've just started, I tried hardy kiwis, they didn't work. So now I'm growing grape, champanelle grape, and they seem like they're gonna work. They'll be in their second year. Next year, hopefully we'll cover that trellis. And to the right, I pulled out, what you're looking at is red raspberries. Don't try those here. By the way, that was a mistake. I mean, I've got raspberry crops, but so much water, it just takes way too much water. So I have in that place now asparagus, which I'll grow, and it seems to be doing well there. So I've had to change my crop selection and just change a lot in the strategy on how I water and I shade my backyard to handle what I suspect is going to be, you know, the new climate. The best way I explain it is that the climate that you grew up in is not going to be the climate you're going to live the rest of your life. It has been slowly changing, and now in the last 10 years, that pace has picked up. It's been changing a little bit quicker, and I don't think it's going to change back. There would be no reason to think, given the change in global patterns driven by extreme water temperatures, that we're ever going to get our old climate back. The only thing to hope for at this time is concerning our heat is that as we raise the water vapor amount in the atmosphere and so close to the Gulf of Mexico, there is a chance we can start getting more cloud cover, which would alleviate some of the heat, but at a price. As you know, when it's 100 degrees, if the dew point is in the upper 50s, there's no heat index. If it's 100 degrees and the dew point gets in the upper 60s, Now there's about a 10-degree heat index. That's the threshold, about upper 50s to when it gets in the upper 60s. It doesn't sound like a big range, but it's everything as far as how it feels like out there, because on a 100-degree day and a dew point in the upper 60s, it's not very pleasant out there. And we've had dew points this year in the mid 70s during the summer, which is unusual. Like I said, we broke a record for most days dew points in the mid 70s, along with our record hot summer as well. I can take any questions, but I just have to say that we're in a weird point in our industry where we're like in junior high school again. We have to all be popular. I don't know how this happened, but if you could follow me on Twitter and join me on Facebook, my managers like to see those numbers. I did this for the science and protecting people during severe weather. I can't believe I have to shield to get people to like me on social media now. I was talking about the atmosphere, and as you know, we changed it fundamentally with the increase of carbon dioxide, and it's followed the temperatures up. But I really wanted to get to this slide because when I was telling you that this new climate that we're going to be dealing with now, it has everything to do with the graphic you're looking at. The oceans are getting warmer because the oceans for the first 150 years in the industrial age took most of the excessive heat that was being formed by the CO2 put in the atmosphere. It was actually absorbing the CO2, and it was also absorbing the extra heat, about 90% of it. What you're looking at is since the 80s, the average global temperature. This is taken from about 30,000 sites across the globe. And it can actually be calculated on a daily basis now. But they have a running average always as well. And you can see what happened this year. Something remarkable happened this year. It probably had a lot to do with El Nino kicking in so rapidly, but the oceans were already warm before El Nino kicked in. And so this is like putting the foot on the accelerator. So what you see in that red line is what's happening this year. And below it is the average temperature of, or the same, at the same period, over 30 years of observations, actually 40 there. And you can see there's been nothing like this year. So that's why I'm not optimistic that we're going to get our old climate back, at least in our lifetime. We can take any question anybody has about any of these numbers. I've been studying and compiling these for some time, so there's a lot of other information in there as well if anyone is curious about it.
Okay, this is Marion, Ray. I was going to read the questions out in the chat like Dick had asked. First one is, I see a lot of trees that look dead. Does data support that many more mature trees are dying? Will many dead-looking trees that shed their leaves recover?
Most will recover. Any tree can handle pretty much defoliation, even a couple defoliations within a single year, and still survive. They've evolved that way. I would tell you that most arborists are concerned about not only the intensity of the heat we're getting now, but these warm nights could be a big problem. I know that the Texas Tree Foundation, an organization I've done several stories with on this, they've been around here for about 40-something years. They're going to change their list of recommended trees. They're going to willow it down. That's a long work in progress because of all the research it requires. But right now they feel comfortable where they used to be able to suggest as many as 40 different trees. They're comfortable suggesting 5. And it's because trees that can handle the heat as well as the long dry spells. Now, some of these are native but most of them are native in just the next warmer climate to our south or drier climate to our west. So they're looking for trees that work in extreme forms of our own weather. And their greatest fear is that over a decade of these warm nights and intense heat summers, we could just start simply losing a lot of our canopy of native trees, because the native trees haven't seen overnight temperatures like this.
Wow. Okay. You are let me see, I'm sorry. You're adapting your garden to the current conditions, but what can we do at the local or even regional level on municipal properties? Any suggestions?
That will have to be changing over to drip irrigation, mulching as the new religion of plant growing around here, and plant selection. The only way to mitigate the changing climate is to adapt to it. These are our best strategies that we have right now. And all we can do is hope that there is some kind of balancing, that the upward trend at some point plateaus, and that we don't lose our native vegetation here because the weather pattern changed so much here. So I would say just basic strategies that are being employed by many municipalities now will have to be embraced by all municipalities. And of course, you're probably thinking in your heads already the big props to go with that is when it comes to trees, the best time to plant a tree was 10 years ago. So there might be a lull in the action there, a lull where we don't have the canopy amount that we want and are trying to grow it as rapidly as we can.
Is it true that coal-fired plants are the biggest contributor of excess CO2 in the atmosphere and not gas-powered vehicles?
Yes. When you look at the long arc of us putting in CO2 into the atmosphere, it is mostly from power plants and industrial. Farming actually puts in a lot of carbon and methane into the atmosphere as well, agricultural practices. If we were to attack this problem in a true manner, which I don't believe we have yet as a society, because CO2 emissions continue to rise every year, it will be a multi-pronged work from many directions, doing many things. But we will have to address the burning of fossil fuels eventually. We'll just have to transition out of it because we already have CO2. I can show you the chart. First off, the startling statistic of where we are now, on the left in the green is the entire biomass of this planet in plants and how much carbon is in that biomass. This doesn't count the oceans. This is terrestrial surface. And on the right is all the carbon we released into the atmosphere. So it's now equaled everything growing on this planet as far as amount of carbon. But that's where we're at today at 416 ppm. The general thought is once we get up to like 430, we're going to be at what the tipping point has always been considered up, for what it's worth. This is the greatest experimentation in the history of mankind. We do believe that there is going to be some consequences if the average global temperature gets to 1.5 Celsius above the pre-industrial average. It has to do a lot with global ocean currents and what happens to the ice. But if we get to 1.5, we could start a whole chain reaction. So we've been trying to get to mitigate carbon emissions to keep under that target. Now, to be honest, we don't know what happens at 1.5. We actually got above it briefly this summer, and we kind of got a glimpse of it. But the count obviously is something we have to work on from every direction to start to lower. But we're gonna have to start by somehow getting off fossil fuels. But I don't know how that happens anytime soon.
Okay, get an excellent presentation comment in addition to a question. Do you think there are technologies that can be developed to reverse these trends, like carbon capture?
I would hope that a country that can put a man on the moon and win a world war can figure out this problem. So I've always stayed optimistic about our abilities to think our way through a problem, no matter how huge it seems at the time. So carbon capture would be a way. They're talking about shading the planet from space. Some really crazy ideas out there. But I think 50 years from now, none of this will sound crazy. You know, we're going to have to do something to remedy it, because if we get to some kind of tipping point that we don't know what happens when the permafrost starts to release its methane? What happens if the waters on the northern latitudes get warm, where they release all the methane that's trapped at the bottom of those water bodies? And we could get into a rush of methane, which is 27 times more potent than CO2 as far as warming our atmosphere. I mean, we could put in motion something we did not intend to put in motion. And then we would have to engineer our way out of it. But I'll be honest with you, and I think you see this too. I think step one is like in Alcoholics Anonymous. Step one, you got to first admit there's a problem. I don't think everybody's.
Okay, what are the potential high temperatures and related frequency in summers, say 20 years from now? I believe I've read that it's predicted to be above 100 degrees Fahrenheit.
It is, again, an experiment we're running on the whole globe. We do think there's going to be some feedback in cloud cover and high humidity. And we don't know where that leads us as far as storm pattern. That is unfortunately a glimmer of hope of some relief from current trending. If the trends just stayed the way they are, if you would draw the line from, say, 23 years ago, let's say we'll start it at the turn of the century, when things seem to really start getting warmer and sticking around, that would suggest that what our top third hottest summers will become our summers, and that our record summers would be unfathomable. I mean, you know, you've been out there today. I mean, this summer you've been out when it hit 110. And the idea that we would live in a climate in the summer here where 110 would be like the new 105 would be very difficult, not only for the populace, but very difficult to maintain our strategy on cooling all these homes. Cost a tremendous amount of energy to cool so many homes when the weather is that hot. And quite honestly, we didn't build the right houses 10 years ago. You know, you can't argue we didn't see it coming, but we certainly didn't change our construction of homes here. Probably 20 years ago, we should have done it. What they can protect it, a house can protect itself from that kind of summer heat with the right insulation, right type of roof, and all the things that it, you know, in design that it takes to handle hot temperatures. A lot of people, honestly, are living in the wrong house for what's coming down the road.
Kind of in that line, there's a question about, are there going to be some better states to live in than Texas? I've been looking at Arkansas, New Mexico.
Well, I can tell you what I did. I've decided to retire at 68. I'm not going to work to 70. I bought 10 acres of land at a higher elevation in Tennessee, southern Tennessee. I was able to narrow down a couple of places across the United States that I felt comfortable with, as far as what the climate might look like in 30 years. Would this be a smart place to live? A lot of variables went into that calculation. One of the key ones was altitude. I wanted to get higher up into the atmosphere where I have cooler nights and take the edge off the summer days. I also looked for a place that had consistent rainfall patterns so it'd be less prone to drought. And then there are basic things, place not prone to forest fires, not prone to earthquakes. And so I found a place in Tennessee that kind of fit that bill. And in 2 years, I'm going to move there. I'm starting to build the house in 2025. And I'm going to start a truck farm operation there. I'm going to do what my grandfather did. He was a farmer. And that's my plan. Everybody's going to have a different plan, but I'll be honest, guys. Sometimes I wish I didn't know what I know. I've been talking about what we've been doing to the atmosphere since the early 90s, late 80s, actually. And it seems the longer you follow it, the more frustrated you are with what has happened, what's happening now, and what's going to happen. But we all have to act as a community to try to do something about this. And I hope all of us will find the fortitude to do that, to work together.
Kind of on that line, I'm going to interject my question. Is there a lot of pressure? I've heard on meteorologists who talk about climate change. Is there pressure against doing that?
For years, I've been very cautious. This is that very effective way to counter an argument, is that you make it not about the science of the argument, but the politics of the argument. I'm in a business that requires people to watch me on air. I get assessed by, in essence, my popularity. You risk that if you talk about a political subject. You almost immediately divide your audience in half. And I would say in this area of the country where oil and gas is a very important part of our economy, I would say it's more than half. So for decades, I've been kept silent because of the subtle economic and political pressure that's put on all of us not to talk about. But at this point, when things have become rather obvious now that we're going to be dealing with this problem, certainly for the next generation or two, I think it's a little easier politically to talk about it on air. I would hope so. I've been doing that. I have the full support of my management, but our business model has changed considerably over the last couple of decades. And I really find that makes the whole business a little unpredictable itself. I hope we can continue just informing people of what they're actually seeing in their backyard, and what's happening in their backyard is systematic to what's happening just about everywhere else in this globe.
Thank you. Is all the methane from our many Texas cows a huge problem?
They only assess agricultural inputs at about 6%. So there are many other problems to attack first, I would say, before we get into disrupting food supply. I will tell you that there are several things being done as we assess the industrial food complex, the way we grow crops here. that maybe we don't need as much corn or soy because most of that is going to feed beef and pigs. So that might have to be reassessed. That would also greatly reduce methane release because the big culprits, by the way, happen to be those practices. So if we could address the worst of practices that are going on across the United States agriculturally, that would put a big dent in the contribution to this problem put forth by agriculture. I still have a lot of hope that agriculture might offer a lot of solutions in the end for carbon capture, carbon sequestration, that we can actually start to take carbon out of the air with plants and store it in the ground that way. There's a lot of research going on right now, and the initial reports, makes you not as optimistic that it's going to be that easy. But I think there is a way we might be able to grow our way out of this problem, or at least a large part of the problem.
Sorry to put you on the spot, but does a Marvin Nichols reservoir that would level 6,500 acres of trees make sense given what you know?
It makes sense for our water supply. It makes sense for the people living here. It doesn't make any sense at all for carbon budget. But that wasn't part of the decision, was it? The decision wasn't based on the carbon stored in those trees. The decision was based on if we had enough water for people, the amount of population will be here 20 years from now. We're growing at just a little under 2%. That means in a little over 30 years, we'll have double the population. So we're going to need a lot of water, especially if summers continue to go like this.
We see the tops of some plants scorched. How can we prevent this?
There's going to be a lot of study over the next 5 years on what are the recommended plants here. Again, I think the biggest driver are going to be these two factors: the intensity of the heat now and these nights over 80 degrees. So what you might be looking at, these scorched plants, I hope they recover next spring. You'll know then if it's permanent or just a bad growing season for them. But I think in the long run, I go back to plant selection. We're going to have to probably change what plants actually are best fitted for this area.
Okay, there's a couple more questions, but I also want to say you got a lot of kudos, convincing and very sobering. Your numbers make the case overwhelming. Thank you. Several other awesome presentation. Thank you for your time and your candor and informative presentation. You can look at the chat to look at all those in a little more detail, but also a couple of questions. Do you have a chart on the methane climb as you do on the CO2 climb?
No, but I think I can get that either out of the Yale Climate Connection people or the Climate Connection people, because they've done research and have done longitudinal studies on methane as well. I'll try to find one.
Okay, one more question. What about the new ultra white paint for roofs, roads, etc.?
That's very smart. Anything that reflects the heat back into space is a smart thing to do. The biggest problem facing us globally is the loss of ice on both ends on both poles. That ice reflects sunlight back out. When you get above 32 degrees, that ice becomes water or exposes land, and now it absorbs the heat. So we need to counter that and start reflecting more sunlight back out. White roofs would be a good idea. They certainly are going to be good in microclimates. You can literally cool down a city. And they've shown this by, there's several strategies, but one of the main ones is reflective roofs and lighter colored pavement and trying to build corridors where you get better wind movement and using canopy areas to get cooler, to get pools of cooler air that you then move through corridors. If you read a study on what Singapore has done, they've led the world in urban design for heat, the answer warming, for them a warming ocean since they're right on it. And they have pioneered a lot of these techniques that are going to be used in now the Southwest Medical District, which is going to get a total remodel. They're going to totally redo the road there, Simons, that comes through the hospital district, and put a park at the end. It's tremendous expense, but they're using all these inputs based on computer modeling of wind flow and where the heat builds up and where the pollution builds up. And it's all going to be designed to make that area more comfortable. They're going to learn a lot, already learning a lot, and learning a lot that can be applied to other parts of this city. So we will have to rethink our urban design over the next couple of decades on handling this new climate.
Hey, I think that's the last question. I'll double check at the bottom, but I scroll back up. Just there was an announcement about a upcoming program at the Sherry K Park Nature Preserve on bats in the bats of the area, and it's on October 14th between starting at 7 o'clock. And those people who can have gotten the link to the newsletter, it does give more detailed description of where it is. And if you haven't gotten the link to the newsletter, put your email address in the chat and we can get that sent to you. And Jeff, I'll send you the links to the newsletter, and I'll download the chat so you can see the comments about your presentation and look at the questions too.
Thank you, Mary. And again, thank you for inviting me to talk to your group. I'm real glad that you guys have a group of people that can, start attacking some of these problems that we're seeing just in your immediate area. There's a lot to be done here over the next decade. And I hope you guys are part of that.
Thank you very much. We appreciate
Thanks.
it.